Somewhere in the universe, a star is dying. Not with a quiet fade, but with a collapse so violent it tears reality itself. And from that death, something impossible is born. A place where time stops, light disappears, and the laws of physics begin to break. This is the birth of a black hole. Black holes are not just objects, they are consequences. The universe doesn't create them randomly. It follows rules, strict, unforgiving rules. And according to modern science, there isn't just one way a black hole is born. There are multiple paths, each more extreme than the last. In this journey, we'll explore every natural way the universe can create a black hole, from dying stars to collisions to the very birth of the cosmos itself. Method 1. Stellar collapse. Every black hole story begins with a star, but not just any star, a massive one, at least 20 times heavier than our sun. Inside this star, a battle is constantly being fought. On one side, gravity, trying to crush everything inward. On the other, nuclear fusion, pushing outward with immense energy. As long as fusion continues, the star survives. But fusion cannot last forever. Eventually, the star runs out of fuel. And in that moment, everything changes. The outward pressure disappears, gravity wins, and the star collapses in less than a second. The outer layers explode outward in a supernova, one of the most powerful explosions in the universe. For a brief moment, this dying star outshines entire galaxies. But at its core, something far darker is forming. The core collapses endlessly, crushing atoms, crushing protons, crushing even the structure of matter itself, until finally a singularity is formed, a point of infinite density, and around it an event horizon, the boundary beyond which nothing can escape, not even light. The key is mass. If the collapsing core is small, it becomes a neutron star. Massive enough, it becomes a black hole. There is a threshold, a limit beyond which nothing can stop gravity. Imagine compressing Earth into a marble. Now imagine compressing the sun into a city-sized sphere. That's the level of density we're talking about. Scientists have observed these events across the universe: supernova remnants, X-ray bursts, gravitational signatures, all pointing to one truth. Black holes are not rare accidents. They are natural outcome of stellar evolution. Every black hole formed this way is a graveyard of a star, but also a doorway to deeper physics, because inside them, our understanding of reality begins to fail. Transition to next methods. But stellar collapse is only the beginning. The universe has more extreme ways to create black holes. Some don't require death, some require collisions, and some may have existed since the very beginning of time. What you've seen is just the first path, the most common way black holes are born, but not the most mysterious. In the next part, we'll explore black holes formed through cosmic collisions and those that may have existed right after the Big Bang. Subscribe to Science in Silence, because the deeper we go, the darker it gets.
Not all black holes are born from quiet death. Some are created in violence so extreme that space itself begins to shake. Collisions, mergers, unstoppable gravity. In this part, we enter the most chaotic places in the universe, where black holes are not just born, they are forged. In Part 1, we saw how massive stars collapse to form black holes. But the universe has other methods, more brutal, more unpredictable. Here, black holes are not simply created, they are built through cosmic collisions. Method 2. Black hole mergers. Imagine two black holes drifting silently in space, invisible, yet unimaginably powerful. At first, they orbit each other slowly, but gravity is patient, and it never lets go. Their orbit tightens, faster and faster, until they begin to spiral inward. Space itself starts to ripple. These ripples are called gravitational waves, tiny distortions in space-time traveling across the universe. Then, in a fraction of a second, they collide. No explosion of fire, no sound, just pure gravity merging into something bigger. A more massive black hole is born. In 2015, scientists detected these waves for the first time, a signal from two black holes colliding over 1 billion light-years away, proof that these cosmic mergers are real. Method 3. Neutron star collisions. A neutron star is what remains when a massive star dies, but not massive enough to become a black hole. It is incredibly dense. A single teaspoon weighs billions of tons. The collision. Now imagine two of these objects spinning around each other, locked in a gravitational dance. As they spiral closer, the energy builds. When they collide, the result is one of the most powerful explosions ever observed, a kilonova. Brighter than a supernova, more violent than anything we can imagine. If enough mass is combined, the merged object collapses instantly into a black hole. These events don't just create black holes, they also create heavy elements, gold, platinum, the very materials found on Earth. Method 4. Direct collapse black holes. What if a black hole didn't need a star to die first? What if it formed instantly? In the early universe, gigantic clouds of gas existed, thousands, even millions of times the mass of our sun. Under the right conditions, these clouds didn't form stars. They skipped that step entirely. Instead, they collapsed directly into massive black holes. No explosion, no supernova, just collapse. These may be the seeds of the supermassive black holes we see today at the centers of galaxies. Method 5. Runaway stellar clusters. In some regions of the universe, stars are packed incredibly close together, millions of them, in a relatively small space. Here, collisions are inevitable. Stars crash into each other, merge, grow larger, more unstable. One massive object begins to dominate, growing larger and larger until gravity takes over completely. Eventually, it collapses into a black hole, born not from a single star, but from the chaos of many. In these extreme events, black holes are not just the end of something. They are the result of interaction, collision, and chaos. The universe doesn't just destroy, it reshapes. But even these violent methods may not be the most mysterious, because some black holes might not come from stars or collisions, but from the very beginning of time itself. Black holes from collisions, from chaos, from pure gravity. But what if some existed before stars were even born? In the final part, we explore the most mysterious origin of all, black holes from the early universe, primordial black holes, and the possibility that they still exist today.
What if some black holes were never born from stars? What if they existed before galaxies, before light, before the universe even became what we know today? This is not science fiction. This is one of the most terrifying possibilities in modern physics. In Part 1, we saw stars collapse. In Part 2, we saw violent cosmic collisions. But now, we go further back than both, to the very beginning of time itself. Method 6. Primordial black holes. Right after the Big Bang, the universe was not calm. It was chaotic, dense, unstable. Tiny fluctuations in energy filled space. The possibility. In some regions, matter may have been slightly denser than others, just enough for gravity to take over instantly. Instead of forming stars, these regions collapsed directly into black holes. No supernova, no collision, just pure, immediate collapse. Primordial black holes could be as small as an atom, as massive as a mountain, or even larger, completely different from anything formed today. If they exist, they could still be here, hidden, invisible, drifting through space, even through galaxies. In the early universe, physics behaved differently. Temperatures were extreme, energy levels were unimaginable. At these scales, quantum mechanics and gravity collide, creating conditions we still don't fully understand. Tiny fluctuations in space-time could grow rapidly, and under the right conditions, collapse into black holes. Studying these objects could reveal how the universe evolved, what laws governed its earliest moments, and what still remains hidden. Most of the universe is made of something we cannot see, dark matter. It doesn't emit light, it doesn't interact normally, but it has gravity. Some scientists believe primordial black holes could be dark matter. If true, then black holes are not rare objects. They are everywhere, surrounding galaxies, holding them together, shaping the structure of the universe. Imagine billions of tiny black holes, invisible, passing through space, even passing through Earth without us ever noticing. Some theories go even further, suggesting black holes could form in ways we've never observed. Hypothetical cracks in space-time, called cosmic strings, could collapse under tension, creating black holes instantly. At the smallest scales, energy fluctuations could become so intense that they collapse into microscopic black holes. Some theories suggest extra dimensions exist, and under certain conditions, black holes could form through interactions across dimensions. These ideas are not proven, but they are taken seriously because they follow the mathematics of our universe. Black holes are not just the end of stars. They are not just the result of collisions. They may be fundamental to the universe itself, born at the beginning, hidden in darkness, shaping everything we see and everything we don't. From dying stars to violent collisions to the birth of the universe itself, black holes are everywhere, silent, invisible, unstoppable. If this changed how you see the universe, subscribe to Science in Silence, because the deeper we go, the more reality begins to disappear.